this webinar, we're going to start by covering what's a DTA, and then we will cover different DTAs based on the industrial sector, whether it is transmission, distribution, alternating current monitoring, communication monitoring, data logging and storage or historian applications, data reduction and summarizing, data conversion. Then we will take our first Q&A session. After that, we will start with our calculator configuration section. We'll give you an overview of how calculator work and basically a step-by-step of the calculator configuration using sgconfig. And then we'll start our second Q&A session, during which we will have a 10-minute break after, and we will start the D20MX Mailbox DTA configuration. In the Mailbox DTA configuration, we will show you an overview of the Mailbox, what is it, how does it work, and then a step-by-step of the configuration of the Mailbox. We'll close with a final Q&A session. Okay, so let's get to the first subject on the D2X DTA overview. Over the years, GE have developed many applications for the automation platform. Well, the application that we are interested in today is the data translation application, or DTA. The DTA has been developed for many platforms, for example the D20M, M++, M+, ME, ME2, MX, D200, D25, iBox, and the iBox kit. And in all of these platforms, more or less the DTA would do the same job. Some DTAs were developed for specific platforms, for a specific customer, and carry the customer name. Some DTAs were developed across all the platforms, so it works in the iBox, in the D25, in the D200, in the D20. Some applications were very generic, some of them very specific to the industry. So for example, some of the generic applications that we give to every customer who purchase a D20 system or a D25 or an iBox is the calculator application, A083. And it's a very useful application, very powerful. You can build logic in it. You can build very complex logic in it. I've seen customers with building something that as complex as a requirement for a ladder logic inside calculator. Also, we've got the ProLogic and the Logic Links application, which were developed over the year to allow customers to program using IEC standard programming languages, and that allowed the customers to put ladder logic functional diagrams inside the D20. The D20 is a very powerful box that allow you for execution of these of that logic. So what happened is customers would find a certain logic to be useful in the field, but they require it to be executing efficiently and not via the interpretation of the ladder logic. So they would approach GE in order for us to create a specific DTA for their industry sector. GE would evaluate it, and if we found it that it is common to a lot of customer base, we would have developed this DTA. Now, what you have to know as a user of the remote terminal unit is that if you're thinking of a certain application or a certain logic, let's say you want to OR all your digital inputs, we could have a DTA that will service your need. For example, Common Alarm DTA, Data Translation Application. And the Common Alarm DTA will allow you to take a whole bunch of digital inputs and change them into a single alarm point, all right? There is many applications that serve the generic need, and there is applications, like we said, that serves the specific need. So for example, there is also the substation maintenance application, which means that you turn this on, and then no alarms will be transmitted to your operators while maintenance is taking place, right? So you don't want false alarms at your operators. Okay, so now hopefully you have an understanding that these applications exist in not in all the platforms, in some of the platforms, and some of the applications are generic, so they have a generic application. Some of them are very specific. So I'll try to demonstrate throughout this discussion that the specific one that are useful per industrial sector. The information would be created in the field as digital information from a sensor or a meter that's measuring something, or a relay that's taking certain important action, or from a peripheral like an I/O card that is connected to these sensors or inputs from the field. Once the information is available in the field, it's then formatted in a protocol and transmitted to the physical port that it is connected to. That physical port could be either a serial port or a network port. There is an application that's constantly monitoring that port for information that is of interest, which is the data collection application family of protocols. So it could be either a DMP data collection application, or a Modbus data collection application, or a 101 data collection application. That data collection application would take that information that is received from the physical port, decipher it, figure out the important information that needs to be stored in the WIN database, places that information in the WIN database. Now what we have inside our WIN database is physical data that we received from the field. That information would then be pulled out by a data processing application. The data processing application would format the information in order to send a reply. The reply will go to the communication port, the target physical port that is connected to a master. The master would receive this information that's of interest and then present it to an operator. One thing to note here is that if the information that's received from the field inside the WIN is not the information that the master wants to view, or the master requires that information to be manipulated or changed, then that is where the DTA come into play. The DTA picks up the physical information, change it, manipulate that information, and then put it back into the WIN database, right? The DTA has other strength where it can monitor the communication. So it can monitor the communication between a data collection application and an IED, and whenever it sees no activity or there is a drop of a certain RS-232 signal, it can raise a digital input point or an alarm. So in this case, it's putting information not about physical information that was received in the field, but behavioral information that will talk about certain status that took place in the remote terminal unit. It can also pick up information or make information available to masters so that masters can behave or issue commands as required. So for example, it can stop or lock a master from sending a digital output to the field if that master doesn't have control of that digital output on the field, and I will elaborate on these applications. This section will discuss the generation, transmission, and feeder bay data transmission applications. In the data translation application generation and transmission, the applications that are available include the definite time protection, so over time, how many multiple of pickups took place, breaker failure protection. So it's similar to the protection that happens in a relay, but you can do it in a bay. Synchronism, that's basically synchronizing the voltage between 2 buses, and local remote switch setup. Normally we have a manual local remote switch, but you can do also implement a software local remote switch, automatic voltage control, secondary master trip close, set point adjustment, tap position indication, and automatic load restoration. In this section, we'll provide you a brief idea of the available applications in the distribution automation sector. For a distribution automation, some of the applications, as you can see in the example, will include an auto recloser and automatic restoration when there is an outage out there. How can the intelligent electronic devices figure out how to restore the power? And to do that, they would rely on bays and like the D25 bays, or intelligent electronic devices like the D400 or the D20, and applications DTAs like a distribution capacitor control algorithm, or fault localization, load and dead bus transfer, load shedding curtailment applications are all examples of DTAs that has been developed and available, so you don't have to build the logic in your logic links, as we said, or your ladder logic in order to carry out this very complex logic. And instead, all the logic has been built. You can just request the application and include it in your list of tools that can be used in your substations. In this section, we're going to discuss alternating current data translation applications. For the AC applications, the AC applications that were developed for the DTA include the AC analog alarm data translation application that basically provides alarms based on certain AC values. Data profiling data translation application, and power quality data translation application. The digital fault recording application, the supplementary AC data application, thermal demand metering application, and last is the statistical data application. Okay, next we will list the applications that are available for communication monitoring. As you can see in our demonstration for the communication monitoring, for example, there is a communication watchdog application, and the designer decided to create it using this bulldog or watchdog that basically signify that when there is a message or a communication loss, that alarm is generated by this data translation application. Earlier I mentioned the substation maintenance application, which basically stops any alarms going from the substations when there is work being carried out in the substation, so that to avoid false alarms going to the operator. The virtual terminal or the pass-through is a great application. Sometimes you have a software that basically wants to connect to a field device, but it cannot deal with all the inter gateways and inter remote terminal units. So this pass-through application would allow that software to feel as if it is connecting directly, even though it's going over multitude devices and network from one point to the other. LAN services applications, communication statistics in order to measure how much loss of messages took place. Of course, the time protocols, which include the IRIC-B, the HOP, the SNTP time, and finally the data display applications, which sits in like a bay or in a D20 chassis, and basically displays the data using an interactive touch screen. These are some of the communication monitoring applications that's available for the field services. In this section, we'll briefly discuss the data logging, storage, and historian applications. In substation, normally the data is very constant, but sometimes the data do change over time. So when there is a change in data, it raises an interest for the operator. So if the data is changing without a time tag, you cannot put the sense around what happened first, what happened second. So you cannot put it in a sequence. So a change of state without time, we call it a COS. We refer to it as a COS, or a change of state sometimes. And change of state with time, which means you can put it in sequence, so every change of state that takes place is logged into a database, into a historical database and event database. You can look at it, and then you can put the events and sort them by time. That's a sequence of events, so it's referred to as SOE. The SOE logger would allow you to collect that data and put it in a file that can be uploaded from or downloaded, whichever way you look at it, from the chassis, and then it will allow you also to print that information to a nearby printer if required. So that's the job of an SOE logger. An accumulator freeze DTA is an application that will allow you to periodically get a snapshot of the accumulators or the counters as they continue counting, and you want to make sense of the data over a period of time. So periodically it will take that snapshot and make it available to be loaded or analyzed. And of course, all of this can only happen if we have an event storage and a historical analog system, that analog and digital system that keeps logging this data and save it for us to analyze this data. In this section, we're going to briefly discuss the data reduction and summarizing data translation applications. So some of the applications that will assist you in reducing the data and summarizing it so that we can make sense of it include the analog reference data translation application, the data change detect application. If you're only interested in the changed information, not in the static information, alarm prioritization, analog averaging, analog alarms, top of the hour or TOH, analog averaging, redundant IO, which allow you to get data from two sources. If one source failed, then you can get it, or also to compare that the value that you're getting is really what you should be reading. And the debounce monitoring. I talked about debounce in earlier modules, which is basically when data is changed in a very small period, whether that change is significant to log or notify of the change, or just ignore that little debounce change. In this section, we're going to talk about data conversion applications. In a substation environment, there is always a need for converting either analogs to digital or digital to analogs, or convert an input to an output or an output to an input. Convert the type, whether it is 12-bit to 16-bit, 16 to 12, or so forth, and like 32 to 64-bit. And sometimes the data comes without a timestamp, so you need to timestamp it upon receipt of the data. So all of these applications or needs that showed up over the years, the customers have approached GE for a special data translation application that will help you do these conversions without the need to write the logic, and you can see the list of applications that will assist you in this field. Just to summarize, you don't need to create the logic yourself. Most of the logic sometimes have been already created and ready and available for your application. There is documents that are available that will list all of these applications. We just went through a brief discussions of the available applications in the for the D20 or D200 or D25 iBox family. And what we covered was a brief listing of these applications so that you're aware of the available applications that you can request from our development team if needed, and the applications including applications that belong to the generation, transmission, distribution, analog AC analog monitoring, communication, and then all the data manipulating applications for summarizing and conversion. Thank you for your questions. Okay, so we will start. The first question is what kind of document would list most of the DTAs that we have? There is a lot of documents. Every DTA that we have has a configuration guide, but a very good document reference that you can download from our technical website is the PRPI 048, which is the D20-2005 iBox applications, and basically lists all the DTAs with a brief description of every DTA functionality. All right, the next question, a very good question, is what is the difference between logic links and ProLogic? ProLogic is our older ladder logic building application, and Logic Links is the newer one. It's available in 16 and 32-bit compatibility. Basically, it comes in 8 and 16-bit, and this is a little bit of confusion. So the 8-bit is compatible with the 16-bit Windows, and 16-bit is compatible with the 32-bit Windows. And yes, it does invoke from inside sgconfig. It's compatible with sgconfig for sure. Okay, the next question is when should we build the logic in calculator, and when do we need to go to ProLogic? There isn't a clear decision as to how complex you can make the calculator application. The rule of thumb, if you find that the message or the expression is getting beyond a certain complexity, like the number of brackets, you're going beyond 2 or 3 bracketing, then that means that you should need to go to ProLogic also, or Logic Links. And then the Logic Links is of course complicated. Last question, do we have transformer interlocking logic? Yes, there is an application that's a transformer. You will find it in the PRPI 048. Thank you for your questions, and we'll start our next section, where basically we're going to take you through an overview of calculator and a step-by-step calculator configuration. In order to configure calculator, to build an understanding for how calculator work in an architecture of a D20MX, I'm going to show you a layout of calculator and the rest of applications. The first step, always I say in a lab, is to know how many applications we need to enable. In this case, we're going to enable 4 applications. Okay, because we have a D20C1 peripheral that's communicating via the D.20 port, of course connecting using a straight through D.20 cable. The application that will monitor the D.20C board is the B003 application. So that's the first application that we will enable, which is the B003 application that will constantly scan the C board and take the points, place them in the B008 database, constant update of these points to the B008 database. Now that the physical points are available in B008, we have points that can communicate with the calculator application, and that's the next application that we will enable, which is A083. And A083 will take points, map points from the B008 and place its own pseudo or soft point back into B008. We can monitor these points through one of the applications, which is a B014. That's just like a DPA that constantly collects the application and monitors the application in B008 and displays through a Westmain port for us. In order to view the points on the Westmain port, we would need a laptop with sgconfig on it, and that's connected using a Westmain cable. Okay, so for our basic example, let's say you've got two redundant points that are sensing the same source, right? And for some reason, if one of these sensors fail, right, then we're gonna have those 2 points are different, which we don't like. So we would like to set up an expression, a basic expression, that whenever these 2 points are different, we're gonna raise an alarm. Okay, so to do that, first thing first, we're gonna connect the points to the C board that we have. Now the C board have 16 digital inputs. I'm gonna pick up point number 5 and 10 for the sake of this exercise and basically tag these points. To tag the points, we go to the application B003 and we go to the point number 5, we put a tag on it, let's say first point, and point number 10, we put a tag on it, let's say second point. So now we've got the first point, the second point, which is point number 5 and 10, available in my B003. From the B003, it gets mapped into B008 automatically because it's our application. There is no need for you to go and do that configuration in the B008. Now that the points are available in B008, we can put them into the mapping table of the calculator, which is the digital input map table of calculator. So we're gonna basically go into the digital input map table of calculator, place those 2 points. If you notice in the gray area, these points now are physically point number 1 and 2 inside calculator. So inside calculator, we don't refer them to as point DI5 and DI10. Instead, we refer to them as DI1 and DI2. So always use the calculator map offset, not the physical offset that's coming from the B008. Now that the points are available, we can write our evaluation. Our evaluation will be DI1 not equal to DI10, which means that we write the alarm state. That alarm state will turn our pseudo point or our soft point to on if we reach to this alarm state where both of them are not equal. At the beginning, in the starting point, both of them are off, so they're equal. Our digital input that belongs to calculator will be off. All right, where is that digital input? We have to go into the Win database, add 1 point and give it a description. In this case, that point is the first point available for calculator, which is point number 17 in B008 because the first 16 points are owned by the peripheral C1. Okay, so here, that's where the number 17 comes from. I get that question in the classroom. How come we have number 17 and not number 1 in calculators? Because it is the 17th, is the number 17. So in the database, in the B008 database, what we should see right now, if we did our configuration properly, is we should see digital input number 5 off, digital input number 10 off, and digital input number 17 also off. These points, of course, will be displayed in the westmain using sgconfig if we have sgconfig and a terminal, a VT100 terminal connected to our westmain. Great. And like we said, that constantly B008 is receiving a state, these states, and if a state change takes place, like let's say all of a sudden the digital input number 10 turns to on. So digital input number 10 in the evaluation will not equal to digital input number 5. As such, an alarm state has taken place. Digital input number 17 is turned on. So in B008, right now, I have digital input number 5 as off, digital input number 10 as on, and digital input number 17 as on. And of course, if we have the westmain connected, we'll be able to see them. Digital input number 5 off, digital input number 10 on, digital input 17 on. Okay, hopefully this gives you a good idea of why we're going to carry these steps and what behavior we're going to see in westmain. Now that you have a good understanding of the layout between the peripheral all the way to the laptop, we're going to show you how to set up a simple expression in calculator, configure that in the Win database, and show you the behavior in the Westmate of sgconfig. So we start the sgconfig as per your previous prerequisite labs. So we'll do the same in this lab. We just start sgconfig, create a project. So we click on the GE logo. We put in the project. We put in the project name as D20-408 Okay. Then we click OK. Now my calculator project is ready for adding of a device. Of course, we go to device templates, pick up the 1.5 new installation, depending on whatever firmware that you have of the MX in your lab or on your chassis, that's the MX target that you would pick up. So if you have, for example, version 1.61, which is the latest with this release of sgconfig in your chassis, just pick up that. As you can see, the factory default device naming is given, and now I will have a wizard that will ask me what is the name of my device. I'm going to call it calculator device. I make sure that the device, I uncheck the LAN based because it's not required at this point. Make sure that the firmware version is set up to what's equivalent to my firmware that's in the device. It asks me what is the part number of the main board, 5263001. The SAN is the same SAN, and then we just click next, finish, and now my device is ready for configuration. Okay, so we're going to double click on the device. That opens the application list, and by default the show disabled application is checked. So I'm gonna enable only the applications that I'm interested in and disable the ones that I'm not interested in. So I'm not interested in the IRIGB. I'm also not interested in the LAN manager. And the Internet Protocol stack. So I'm left with B008 and B014, which are already configured. So all I need to do right now is go and configure the peripheral link, which is similar to the peripherals that we have attached to our D20 chassis. As you can see here, you've got an ASKC2 board, so we're going to delete all of these boards. So we're going to add in our C1 board. Then we click OK. And I get the interface for the C board. The point that I would like to pick up is digital input number 5. So first point. And digital input number 10, second point. And basically, I'm going to build a simple expression. When those 2 points are the same, I'm going to have a logic that will tell me they're equal. And when they're not the same, I'm going to have a logic that will tell me that they're not equal using an alarm point in calculator, right? So that's it as far as configuring the B003 in order to bring these points, these physical points, into the Win database. So now we can close the peripheral link, and we want to see the A083 application. So in the disabled applications, we want to enable A083, which is the calculator DTA. So I right click on it, click enable application, say yes. And now my application A083 is ready for configuration. So I'm gonna uncheck the, so we unchecked the show disable applications, and we can see that this is the only applications that we're interested in, which is the peripheral link, calculator, system point database, and Westmeet. Now we can go to the calculator application. Now notice that the version number of this application is 300, unlike the older calculator applications which pull the points directly with their reference from the Win database. This one map them in first and then use them in an expression. So the first step is to take those 2 points, those 2 digital input points, and map them in as 2 digital input points that we will use in our expression. Okay, so in here we go to the digital input map table, and we map in the 2 points. So in the digital input map table, we map in 2 points, which is the first point that has reference number 5 in the peripheral, but now notice it's digital input 1 inside calculator. And the second point, which is reference 10 in the peripheral, has digital input 2 in calculator. Once you have put in your points, now you can do the comparison between point number 5 and point number 10, but please notice that that's basically point number 1 and point number 2. Okay, so I'm gonna, in my expression, I'm gonna say DI1 not equal DI2 is true status. So in the expression under digital inputs table, right, we will simply write this expression DI1 not equal DI2. Okay, and then we click save. Now we can close our calculator table. Job is done. We go into the Win database. And that expression is going to be evaluated into a single point that's in the system point database for calculator. So I have to go into calculator, DTA, go to the points, and name that point as point number 1. Click OK. Now notice that that point will be point number 17 when I go to the terminal emulator and go to the descriptors. In the descriptors, I'm gonna say here digital input 5 equal digital input 10. So now I can generate my configuration. There is no errors, no warnings, so I can connect to my device. Before I do that, I set up my options in order to make sure that my COM port is set up, my baud rate is set up properly, my high baud rate is checked. If it is not checked, check it, then click OK, click connect. Right? If I'm at the prompt, I can start my download. Otherwise, I navigate to the D20 prompt. And to download, I just press F7. As you can see, it will change to the higher baud rate. And now the D20 is going through a reboot. So while the reboot is taking place, I'm gonna summarize what took place in the configuration. All we did is that we went to the application B003, we configured 2 points, and then we went to the calculator DTA. In the calculator DTA, we mapped the points in the digital input map table, and then we took the reference of the point, which is DI1 and DI2, and put them in an expression in the digital inputs, that's with an S, plural, table. And we went back into the B008, or the WIN database, located the record with calculator, and added a point that's gonna take up or pick up my expression. So now we're ready to log into the D20MX. We go into the system data display, digital input display, and here I'm gonna open 2 windows. So this way I can, in this window, monitor point number 17 and point number 10. So I can see the status of point number 17 and point number 10. Now, point 17, which says digital input 5 equal to digital input 10, currently it's off. Because they are equal. So when they're not equal, it's gonna turn into an alarm. So all I'm gonna do is I'm gonna force this point. And now, as you can see, point number 10 is on. And point 17 has turned on. So if I go to the other window, go to point number 5, and force point number 5 to on, now both points are on and the output have turned off. So as long as they are equal, it's not an alarm state or it's off. Once they're not equal, it becomes an alarm state. So depends on what logic you want to show to your operator, but this is a very simplified way of taking a very simple situation that you have at the site where you need to compare 2 digital inputs before you send it to your operator, and send him an alarm whenever those 2 states are not equal. Now that you've seen how to configure a basic expression, let's go and configure a more involved expression. Of course, all of these expressions are coming from the great manual A083 config guide, which you can export from the sgconfig. Okay, so in order to configure calculator DTA, you need to review the A083 configuration guide to create a complex expression, which is the calculator DTA. Right? And then to configure each type of point, when you're writing the expression, make sure you write the proper symbol for that expression. So if you want to use a digital inputs, we'll use DI. For analog inputs, we'll use capital AI. For digital outputs, it's capital DO. And in this example, we're going to configure a very complex expression similar to this one, where you're comparing three analog inputs to each other, analog input 1, 2, and 3 to each other. And if the comparison turns to be true, we're gonna turn it to on. If the comparison turns to be false, we're gonna turn it into off. So this is a very involved if-else statement. Okay, let's see how that works in the configuration. So I go to my peripheral link, and I basically tag the three analog input points that I'm gonna use, which is the first, second, and third point. And then I go to the digital output and I tag my first digital output. That's it, my peripheral link is ready from a configuration perspective. Then I go into my calculator, I go to my analog input map table, and in the analog input map table, I will configure my 3 points, which is first point, second point, and third point. That's 1, 2, and 3 reference. So that's AI1, AI2, and AI3 when I write my expression. And I go to the digital output map table, and I put my point in here, which is DO1. And last, I put my output request, which says if AI1 is greater than or equal to AI2, and AI1 is less than AI3, then I would latch on digital output 1. Otherwise, I will latch off digital output 1. Okay? The same if I want to say it in numbers. Let's say AI1 is 0 and this is 0. So 0 equal to 0, true. Let's say AI3 is 200. 0 less than 200, true. So when AI3 turns to 200 and AI1 and AI2 are zeros, this digital output needs to be latched on. If all of them are zeros, this digital output will be latched off. Okay? And that's it. You're done as far as configuring calculator for this very complex expression. Next section, I'll show you how to configure win. Now that you've got the expression configured, let's configure the win database for this complex expression. So for the A083, the system point database allocation, as in this document, depending on the document that you have, the page is 17, you can see that you need one digital input for any expression that's written in the digital input expression table, the non-storage time, and the storage timer table. So for every expression, you will need to add a point. For every expression in the digital output or digital outputs table, digital output expression table, you need to add a point. For every point, for every timer that you put in the storage timer table, you'll need a counter. And for every analog input expression, of course, you need an analog input. So there is nothing for our table that we have created, which is the output request table in this case. So we don't need to go into win and add a point. But previously, when we put in this expression from the digital inputs table, because this is sitting in the digital inputs table, going back to my document, any expression that we put in the A083DIE expression, we had to add a point. And that's why I like to discuss these points after I show you two different expressions, so this way you understand how to populate the win database based on the expression that you write in. Okay, so now that my win database is perfect, my expression is there, the next step is to look at the points in terminal and see whether those three analog inputs would trigger the digital output and would behave the way we expect the behavior to be. Finally, let's take a look at the behavior of the points that was configured in the win database through the VT100 terminal or Westmain. So in the terminal emulator, I'm gonna go to the analog input display. Now I can see my 3 points, the first point, second point, and third point. I will open a second window go back to my analog input window so that I can see the 3 points in perspective. In this window, I will navigate to the digital output display in order to see my point, which is my first DO point. As you can see, when they are all 0, the digital output is latched off. If I change the value of the third point so that it's larger than the value of the second and the first point, that we expect that this point will be latched on. So if I change the window and go down to the third point, Control F to force it, Control U to update, set it for 200, press enter. I can hear the click on my relay. Now the expression is fulfilled and my digital output is turned to on. If I unforce it and we set it back to 0, now we expect that our digital output goes back to off. As you can see, the expression is working. This is a very involved expression, and you can build even more complex expression based on that very useful documents, the A083. The configuration of calculator in as you config is simplified, and as you can have seen, the first step is to remember that you have to review the A083 configuration guide for the right expressions. Make sure that you're using the mapped offset in calculator, not the offset that's provided by the Win database. When you download your configuration, check the error log first. One of the common mistakes is that students go directly into checking the points before checking the error log. And finally, if you're mapping the points into a DPA like you've seen in the last exercise, make sure that you enable the SOE event reporting in the Win database in the expressions table for that expression. Thank you for questions on calculator. Basically, the first question is a very important question. If I'm going from an old calculator version like the 200 version to a newer calculator version, the 300 version, where a mapping takes place, yes, if you're upgrading, then you have to redo the mapping. It's basically a major change where we go from mapping the points directly from the Win database, and instead of having a local map table inside calculator that does the mapping. So that job has to be done. It's not that difficult once you figure out all your expressions and what points are mapped into the expressions. What is the pseudo points? That again, you will find the pseudo points and the Win database listing in the configuration guide. As I showed you, it's very simple. If you're not dealing with timers, it's a one-to-one. So if you map in a digital input expression, you will need a digital input. An analog input, you'll need an analog input point to pick up the value of the expression. Most of the issues that we see in our customer service with calculator is mostly a mapping issue. So be careful with the mapping and how your pseudo points are being configured. Okay, and with that, no further questions. We'll go to our next section. Basically, we'll start with an overview of Mailbox and then give you a step-by-step of how to configure Mailbox. Okay, so let's get to the overview. First, we will take a 10-minute break. When we want to talk about Mailbox, the first thing is we start with a D20-MX and 2 masters. So the first step is to find out what applications we need to enable. In order to understand that, we have to understand the overall functionality of Mailbox. The idea of Mailbox came from a situation where you've got 2 masters and they want to share information from one master to the other master, but there is no direct link between them. Or the 2 masters control the same field devices and they want to share who's in control. And both masters and the RTU have to know about that status, that who has the ability to control these shared resources in the substation. So normally the masters are talking through a DPA, and that DPA is communicating constantly with the WIN database. And what we will do is we will take a piece of information from the WIN database that belongs to Mailbox and then map it into the first master. Now, when the first master has a status change in it, it can send it to it through its DPA, through the WIN database, the other DPA to the second master, and that information will be available there. So the second application we need to enable is B009, which is your Mailbox DTA, or Data Translation Application. The capability of Mailbox DTA is it can change a digital output to a digital input. It can change an analog output to a digital input. It can change an analog output to a counter. It also can change an analog output to an analog input. Okay? And it will constantly communicate and update its points. So whenever it detects a change in the source, which is the output point, it will change the target, which is the input point. And through the DPAs that are constantly monitoring the WIN database, it will get an update to the masters. Of course, the masters are constantly polling this digital input through periodic monitoring or through on-demand monitoring. In order to see the changes, the last application that we will need to enable is B014. B014 basically will communicate with the WIN database, and through the westmain port, it will connect to our sgconfig terminal and then show us the activity of the points in the sgconfig terminal. Okay? In this lab, I'm going to show you an overview of the lab, how does it work. And next, we're going to show you a step-by-step configuration of the digital conversion. My recommendation is that you watch it first and then you watch it again and try to do the step-by-step process. Okay, with the same layout, first a digital output is created for the B009. We're gonna do that through the WIN interface. We add a point and then we add a description. In this case, the description is gonna be from master 1. And then we add a digital input point in the WIN database again, and we add a description to master 2. Okay, and then of course, if we have the DPAs, we're gonna map it. In this lab, we're not gonna do this mapping. I will leave that to you in an exercise, as you would have good practice with the DPAs from other labs or from previous experience. Okay, and in the B009, we specify the conversion. We specify what is the on state and what is the off state. And this is a great feature. So this way, if the other master has a flipped state sensing, which means that it requires an on to be off and an off to be on, you don't have to go through another conversion step. You can do it in this table. Another great flexibility is one digital output can change the status of more than one digital input. So you can specify a source digital output that belongs to Mailbox. Now notice that Mailbox only deals with its own points, does not deal with other application points. So when you drop down the list, you would see only the Mailbox points. And that's why the first step is to configure the points in the WIN database before you can use them in the configuration table. Once you configure them, now we can specify the conversion, specify how the conversion will take place. Okay, and if you did your conversion properly, when the digital output changes on master 1, that change is gonna show up on the screen for digital input. And if the digital output changes to off, that conversion will show up on the screen. So we will be able to see an on state and we will be able to see an off state. Okay, so you would create a project named D20MX_Mailbox DTA. Inside it, put a D20MX device that's applicable to your firmware number with a mailbox underscore DTA. And you would enable the 3 applications B009, B008, and B014. For the sake of this exercise, we're going to disable all the other applications because it's not required in this exercise. Okay, the next step is to go to the system point database, and we're going to the points. We will add 1 point, which is a digital input point, and 1 digital output point. And then we go to descriptors. For the digital inputs, or in the digital input point, we're going to say to master 2. The digital output, we're going to say from master 1. And then we click OK. Click OK. Now our system point database is ready. Okay, and now the points are ready to be reported in any DPA. If we want, we can go into the mailbox DTA. And in here, we can put the digital output to digital input map. In the digital output to digital input map, we're going to say to master 2, right? And the DI state when the DO state is on, and when the DO state is off, is going to be off. Okay. For the master to master conversion, the same, we're going to do the same. We're just going to say a DO to DI conversion. That's the type of expression. And then we select the source point, which is going to be from master 1. And then we're going to select the destination point. So basically that's it. You're going to select from master 1 is going to impact master 2 point, and if there was more digital inputs, you can also impact them at the same time. And the job is done. You can close this interface, and we can generate this configuration. Now our device has been generated without any errors or warnings. We can go into the terminal emulator, make sure you set up your options in case it's not set up with the proper serial port and the download baud rate. Once you are inside the terminal emulator, we can go to the system functions and navigate to the prompt and press F7 to download the configuration. We get a reboot interface, and then we click the boot. We log in with the normal credentials. First thing first, we check the error log, and there is no errors in the error log. Then we go to the system data display, we open the digital input display, and we open the digital output display. As you can see, there is 1 point which is to the master from master 1. If we force the from master 1, so Control F, and then put in the control password, and we press Control U, turn it to on. Once we press the go, we should see the other point turns on. And yes, that's true. If we change it to off, and the digital input changes to off. Very straightforward, and as you've seen, it's very powerful tool where you can change a digital output to a digital input and then map the points to any DPA that's communicating to a master. In this section, we're going to show you an analog conversion. Okay, so we will configure an analog output to analog input conversion. To do that, again, we open the system point database. And right now we're going to go to the points. We will add an analog input point and an analog output point. Then we click OK. And we go to the descriptors. Under the analog input points, we're gonna say to master 2. And for the analog output point, we're gonna name it from master 1. So at this point, we've got an analog input which is named to master 2 and an analog output which is named from master 1. Then we click OK in here. Now our points are available. Again, all we need to do is to go inside the Mailbox application. So we're going to open the AO to AI map table. And in the AO to AI map table, we're going to select the to master 2 analog output point. And then we go on a master to master and we add the expression AO to AI. We say from master 1, we're going to convert this analog output to the analog input point to master 2. And that's it. Our job is done. Now we can save, close our interface, and generate our device. Okay, the device is generated without any errors or warnings. So we go to the terminal emulator. We navigate to the shell. And we download our configuration. Now we get the interface to reboot the application, and we're just gonna click boot. we log in with the normal credentials. Check the error log. There is no errors. Now we can go into the system data display.
We look at the analog input, and the analog input is set to 0.
And then we navigate to the analog output. So we've got an analog input which is set to 0, and for the analog output we're going to force it. If we set it to 200, let's say, well, now the analog input is set to 200. So as you can see, the whatever message the master 1 value wants to send to master 2, now both points are available. Master 1 can force any point, any value into the point 1 analog output, and the value will be forced in the analog input. Okay, I hope this was an enjoyable experience for you. For the Mailbox DTA configuration, here's a couple of things that I would like you to keep in mind. First, always review the B009 configuration table. Second, map the points in the Win database before you start to configure the tables. Common mistake, people go directly to the configuration tables because they're used to other data translation applications where you can map points from different applications. Remember, B009 only deals with its own points. Third, check the error log for any errors from B009 prior to checking the behavior of the points. Normally in the classroom, I see it a lot. Students would log in, go to the point, digital input points or digital output points, and then it's not working. And the next thing, they're calling me, they're trying to figure out why it's not working. The reason is there's probably an error that's being posted that will point you in the right direction. Maybe you misconfigured the type of point, the type of conversion. It's very common. So check your error log. That will give you a pointer as to why B009 is not acting in the way you expect it to act. Check the DPA requirements for mapping of the points. Maybe it requires an SOE or a COS, and what to do with that in order to make sure that a successful mapping takes place all the way to the master. Last, don't forget the capability that you have in your toolbox right now. Now you've got this Mailbox DTA that can convert a digital output to a digital input, an analog output to a digital input, an analog output to a counter or an accumulator, an analog output to an analog input. You don't have to use it only between two masters. There is a lot of situations where I'm doing configuration logic and I need to convert these points. Also, Mailbox DTA is a great tool to create your own points without the reality of having a point. Let's say you're doing a testing in a lab and you want to simulate some points. The best way to do that is using Mailbox DTA. Okay, I hope you have enjoyed this and see you in future labs. Thank you. This is the final Q&A. This one covers the Mailbox DTA. Nevertheless, if you have any other questions, feel free to post them. I'll answer them as they show up. How does the analog output map to a digital input? The most mistake that's being done when we map an analog output to a digital input is we think that an analog output more than 0 will be 1 and 0 will be 0. That's not true. An analog output is 16 bits, and when you map it to a digital input, every digital input you map it to will pick up one of the bits. So DI0 will pick up the first bit. Now, if you think about it, if the analog output is an even value, then the digital input will end up to be 0. If it's an odd value, the digital input will end up to be 1, because the first bit shifts between 0 and 1 based on odd and even. And the same for the second bit. So if you have the analog output to be 3 and you map it to 2 digital inputs, that means the first digital input will be 1 and the second digital input will be 1. So this is a hex to binary conversion. Be careful with that. Very good questions. Does the pulse and the close work differently when it comes to mailbox DTA? The answer is no. The pulse and the close are the same. So a pulse or an on or a close state is the same, is being dealt the same, and the same for the off state, the pulse off, and open state. Okay. So with no further question, thank you. Thank you for participating in our calculator and mailbox webinar. Just remember that any DTA that you will attempt, it has been either thought of in the industry or has been created in your industry. So before going and writing a very extensive logic, always remember that from the DTA overview, that there is a DTA that will meet your needs. In the calculator, careful with the mapping. Right, one of the most common mistakes in the classroom is the mapping of the points. And for the mailbox, make sure that if you're doing an analog output to a digital input conversion, that you're thinking of it properly, of how the analog output bits are being mapped to the digital input. All the best and good luck with your calculator and mailbox. See you in future webinars.